Dear colleagues, I am Hatice Karadeniz from Bolu Abant İzzet Baysal University. I am working on Chemical Engineering Department and Research Center in that university. Professor Serpil Karakaş and Eda Kancasarlı is in Chemistry Department in the same university. We are working about environmental analytical chemistry. I will introduce a brief summary about my topic and summarizes my results. We know what the particle matter is. The sources can affect the size of the particles, and PM2.5 is harmful for human health because it can be penetrate into the gas exchange region of the lung. There is lots of multivariate receptor modeling tools to examine patterns in environmental data. Positive matrix factorization is one of the such model and data analysis tool which was developed by the US Environmental Protection Agency. PMF allows each data value to be individually weighted. This feature allows analysts to adjust the influence of each data point depending on the confidence in the measurement. The input data of APPORTIONMENT included not only the concentration of each sample data, but also the uncertainty of the data. Also, you can check your results with error estimation methods. Bolu is in the Western Black Sea region in Turkey. It's in between Istanbul and Ankara. As you know, the cities are important metropolis and industrial cities for Turkey. Also, the city is surrounded by urbanized, industrialized cities like Zonguldak, Karabük, Eskişehir, Düzce, and Sakarya. There are two highways, D100 and TAM, connected to Anatolia to Europe, crossing in the city of the Bolu. Also, climate of the city is like Black Sea region and generally warm in summer, cold in winter, and rainy in all seasons. It is also affected from Marmara and Central Anatolia. You can see wind roses in the slide. The main wind sector is west-southwest direction. Height of the mountains increases from north to south, from west to east around the city, and this causes air flows to be trapped in the city in this west-southwest direction. Here is a photography from near the sampling point. The sampling done is in here, and the winds are coming from here and trapped between the mountains. This smoke was seen in the city atmosphere in all seasons. The sampling was performed in SUBURBAN site of Bolu. You can see our university campus in that photograph. Our station is here, and the wind is coming from here. Samples were collected by using stack filter unit. The device has PM10 pre-infector and contains two filters, PM10 and PM2.5. In this presentation, we focus only on PM2.5, and in this sampling, we collected 277 PM2.5 samples. We use polycarbonate filter. You can see the properties of filters in the slide. Sample preparation was done by microwave acid digestion and then open digestion to evaporate the HF. The samples were analyzed by ICP-MS, and you can see the elements which were analyzed in our study. In this study, the mass concentrations of 46 elements determined in 5 PM samples. The equation-based uncertainty file was used for uncertainty calculations. The program examines the relationship between concentrations and uncertainty values and classifies elements as bad, weak, and strong species. You can see weak, strong species in our study. We discarded 22 samples, do not having residues between +3 and -3. Displacement and bootstrap analysis showed us our results were acceptable. No error code was observed in PMF solutions, and it means analysis results were considered valid. The minimum number of bootstrap runs also performed, and 100% mapping were observed for all factors. In that table, you can see our samples concentrations. The most frequently observed elements were titanium, vanadium, chromium, manganese, iron, cerium, and cadmium. Aluminium, calcium, sodium, iron, potassium, and magnesium were the elements having the highest arithmetic means. In our station, the most frequent annual winds were from the west-southwest sector, as I said before, and this carries the long-range pollutants to the sampling stations. Arsenic, cadmium, and uranium had higher concentrations in winter, probably due to the coal burning in this period. The crustal elements are normally higher concentrations in summer than in winter. There are resuspended particulate matters in air in dry season. However, the concentrations of anthropogenic elements like cobalt, lead, molybdenum, nickel, selenium, tin, and potassium had higher concentrations in summer than in winter. In that table, you can see the general pattern of our PMF results. 5-factor was found. Let's examine our results in detail. The first factor is the sea salt factors. The highest contributions was observed in sodium, potassium, magnesium, and calcium. Sodium, calcium, and magnesium are well-known tracers of sea salt. This factor affects the samples in spring, summer, and autumn seasons. Winds coming from west, west-southwest, and east-northeast direction is dominant for this factor. You can see some examples of back trajectories for samples having higher G-scores. From the top of view, the trajectories arriving to the station site mainly approaches from Black Sea region. Here is the second examples for Black Sea region. Factor 2 had high loadings of arsenic, lead, bismuth, thallium, cadmium, tin, selenium, molybdenum. Arsenic and selenium are the marker elements for coal combustion. The coal combustion also may be reasonable for tin and thallium emissions. Besides that, fly ash of coal contains trace amount of bismuth. This factor had highest G-scores in heating season. Trajectories correspond to the high scores, with a few exceptions originate from east, northeast, west, and southwest sectors. These sectors include majority of high heating process emissions area in the city center of Bolu. The trajectories arriving to the station site mainly come from Central Anatolia and Black Sea region. Interestingly, we quote a second similar source, wood and coal burning. Actually, this source may be correct because in the village, wood and coal are used for heating at the same time. Factor 3 has high loadings of potassium, rubidium, selenium, cesium, tin, lead, bismuth, thallium, iron, manganese, and cadmium. This factor In this factor, arsenic and selenium are marker elements for coal combustion, and potassium and rubidium is a marker elements for wood burning. Wind directions also point to the same signs. This factor affects our samples throughout the year. Especially in the summer season, life in the mountains increases in the region. At this point, heating is needed in the evening. These sectors include majority of high heating process emission area in the city center of Bolu. Examples of trajectories coming from the center to our sampling point is seen in here, and from village to sampling points can be seen in here. This factor was identified as soil factor because it included high loadings of crustal elements such as calcium, magnesium, titanium, iron, yttrium, lanthanum, cerium, praseodymium, neodymium, samarium, gadolinium, and thorium. This factor affects our samples in those coming days. West-southwest wind sector is dominant in these factors. When we examine the days having high G scores, we see that dust has affected the concentrations of our samples these days. You can see the highly loaded elements in that slide. Anthropogenic elements such as chromium, nickel, manganese, iron, and molybdenum are released from iron steel works. For this reason, we called these factors as an industrial activity iron steel works. The dominant wind sectors were west-southwest and northeast sectors, and these factors is effective in the summer season. The back trajectories corresponding to the highest factors scores indicates the iron steel works from Karabük and also may indicate the industrial activities from Europe and Central Anatolia. As a conclusion, in this study, daily fine particulate matter were collected in our campus. The most frequently observed elements were titanium, vanadium, chromium, manganese, iron, cerium, and cadmium. Aluminum, calcium, sodium, iron, potassium, and manganese were the elements having the highest arithmetic means. In the Bolu station, the most frequent annual winds were from the west-southwest sector, and this sector carries the long-range pollutants to the station. And the concentrations of elements in the summer seasons were higher than the concentrations of elements in the winter seasons, except arsenic and bismuth. 5 factors was found in PMF source apportionment approach, and these are sea salt, coal combustion, wood and coal combustion, soil and industrial activities. And the wood and coal combustion factor showed the same trend in the region in the whole year. However, higher G scores for coal combustion factor were observed in winter. Long-range transportation is important pollutant sources for the sampling area. Here is my references. Thank you for your listening.
Thank you. Thank you, Ms. Hatice. Thank you for your presentation. It seems to be very well designed study. Is there any question for Ms. Hatice? No?